Good morning, good afternoon, and good evening to all our global audience. I'm your host, Mohan Kumar Saraswatipura, an IBM Gold Consultant and an IBM Champion. I'm with Martin Hubel, my co-host today. Hi, Martin. How are you doing?
Doing well.
Thank you. Awesome. A very warm welcome to the DB2Night show, episode 269, latest from the IBM Development Lab. We are thrilled to have you join us for the special featuring an exclusive DB2 12.1.2 update straight from lab. Mike, how are you doing today?
I'm good. How are you?
Oh, doing well. Thank you. Thanks for taking time to talk to us today.
I'm glad to be here. Thanks for having me.
Get involved. So we have a series of sessions going on. Please do follow us on X, Twitter, then DB2Night show on YouTube as well as LinkedIn. Okay, we have a lot of sessions lined up, series of events lined up for you in the coming months. Each one is designed to keep you informed and inspired and ahead of the curve in the world of DB2, especially within the new release 12.1. Stay tuned and make sure you're registered to all of the upcoming sessions. We have pretty good sessions coming in next month, okay, in coming months. DBI performance webinar. The announcement is about the DBI performance suite, gonna give you much better performance, fine-tuning options or opportunities with a click of a button, right? So just go through our demo, and then if you want to talk to our sales representative, you can please feel free to set up a meeting with them. They're gonna help you with showcasing the efficiency and reliability of the product. Thanks for our sponsor, DBI, Smarter Tools for Smarter People. We will have a few questions coming over on the screen. Move your mouse. We're gonna have a few polling questions. About 20 seconds to provide the response. Okay, so what DB2 version you're currently running? We getting the responses. Gonna close the poll in 3 seconds. All right, closing the poll, sharing the result. So we have 80%, 11.58 or higher, 20%, 11.5, lower than 11.58. That's good to know. Are you planning to upgrade to DB2 12.1? Collecting the responses, 100%. Right? Closing the poll, sharing the result. Everybody said, yeah, we're going to upgrade the database to 12.1 for sure. This session will certainly help you understand all the features available and what you should be using. Are you running DB2 PureScale? Collecting the responses. Okay. Closing the poll, sharing the result. We have 29% yes and 71% no. If you have the sensitive OLTP application, best is to use PureScale for better performance and scalability. What are your DB2 environment challenges? Right? Collecting the responses. Closing the poll, sharing the result. 71% performance and 29% data growth. Are you running HADR with pacemaker in production? This is the new thing with 12. Even this was available with 11.5.9 and 8, but 12.1 you'll have to go to pacemaker. Okay, collecting the responses. Closing the poll, sharing the result. Yep, 50% already on pacemaker and chorusing, 25% still on TSA, and 25% plan is to convert. No plans to convert. They are still standalone. Awesome. That closes the polls. Right, so today's episode brings insight from one of our most influential minds behind 12.1. It is my pleasure to welcome Mike, IBM Db2 Chief Architect and STSM. Mike brings wealth of experience. Let me see if I'm sharing it. Let me hide this. Okay, yeah, sorry. Mike brings a wealth of experience in architecting and shaping DB2 for over 20 years at IBM Lab. So without further ado, please welcome Mike to walk us through the latest from the lab. Mike, over to you. I'm going to make you as a presenter.
All right. Thank you.
Enter. You should see a pop-up on the screen.
Yeah.
Yep, I see a screen. It's a full screen.
Swap it, right? Yeah.
Yep.
Is that correct now? Or nope?
No.
All right.
That's
correct.
That's correct. That's correct.
Yeah, it never works out on my monitors in the way I want it, but that's good. All right. Thank you for having me again. Yeah, I'm going to walk you through latest from the lab. So we will, cover the sort of what's a little bit of a recap of 12.1, 12.1.1 and 12.1.2, and then maybe a little bit of forward looking, which is why this is up on the screen. Some things we talk about, even with 12.1.2, it's not officially out, although it's been announced, could change. So just the standard disclaimers. So again, we'll look at the latest from DB2, sort of an overview of some of the broader strokes, and then sort of do a recap of sort of DB2 12.1 from an engine perspective, as well as look at the mod packs that are out with 12.1.1, is what's coming with 12.1.2, and then what we're thinking of over the life of some of the longer term mod packs. So DB2 has delivered content and technology for 30 plus years now. Lots of new features, functions been delivered over that time. Not everything has been probably aware of and been used. So, make sure you always go back and look and validate that DB2 has something when you hear about it, because maybe we delivered it a while ago and we haven't talked about it as much as we should have recently. The other thing about this slide is really just to reiterate that we've moved to a continuous delivery model. So we do deliver what we call mod packs now. So, the core functionality of 12.1 to get us going from a release perspective was delivered in 12.1, but the functionality of that release will deliver out over the mod packs incrementally across the life of the release. And we deliver fixes now through what we call the continuous special build or cumulative special build process. All right, so that leads into our delivery vehicle. So I want to make sure everyone is aware that we have what we call the Early Access Program, or EAP, and we deliver these both for the GA, but we also deliver EAPs for our mod packs, and I think some people aren't aware of that. So roughly monthly, we deliver an EAP on whatever the current development stream happens to be. Right now, EAPs are being delivered out on the 12.1.3 mod pack because 12.1.2 for all intents and purposes, given its GA date is very much approaching, is locked down and completed. So what you'll see is over the life of 12.1.3, we'll get to a point where we're not we are continuing to maybe deliver fixes and stuff into that stream, but we're not really delivering functional changes, and so that mod EAPs will swap to the next mod pack where the new functionality is now being delivered, so we can deliver out and people can get a feel for what we're delivering and give us feedback early on those mod pack deliveries. New function will be delivered in mod packs, so 12.1.1, 12.1.2, 12.1.3 will incrementally improve on what we have within the 12.1 release. Fixes. We don't deliver fix packs like we did historically. Fixes are delivered through what we call the cumulative special build. Sometimes we call it the continuous special build, kind of the same thing. Processor CSB. And this is where basically we will deliver out the KIs, what were APARs, customers request. So if you call in and want to fix immediately, then you will get an immediate version of the CSV to help you immediately apply your maintenance. But what we also do is we publish out every 4 to 8 weeks, what the latest set of KIs that we fixed over the course of that period of time for anyone to consume easily, having seen what the maintenance is. And that allows customers to apply maintenance on their own kind of schedule, much more predictable, much more flexible way of providing fixes to our customers than the traditional fix pack stream. Our security special builds are also delivered through the cumulative special builds, so there really aren't security special builds like there were in the past. Now we just deliver the security fixes as we need to into that cumulative special build published out on those 4 to 8 week period. If you pick up security maintenance, you are also picking up whatever fixes you would already possibly needed to get from DB2 prior to that. So it makes a lot less friction for moving up from a maintenance perspective. So if we look at the sort of short-term delivery roadmap, so GA was last year in November. Since then, we've delivered Mod 1. Mod 2 will come out very soon, in June, early June. And we're looking at sort of a Mod 3 in the October timeframe or Q4 timeframe. And then obviously you can sort of predict out, well, we don't have dates yet, a Mod 4 will likely come sometime early in 2026. But you can also see that there's some various EAP drops have occurred over the period of time for both the GA as well as the mod packs. I didn't update the slides with dates for the ones that we know we have delivered. And now even Mod 3 will start to see those EAPs come out. So if we look sort of at 2025 and what we're kind of focused on across the board of the portfolio, obviously our cloud infrastructure still remains a big focus of DB2 and DB2 Aero SaaS. Those roadmaps continue to evolve with enhancements around the native object storage, remote storage support, enhancements in our AWS partnership with RDS. But you'll also see that we've moved to new hyperscalers. So we made an announcement about moving to Azure with the bring your own cloud model. We'll talk a bit more about that. So we do continue to make sure DB2 is available across the ecosystem of deployment factors in the cloud. And you'll see other hyperscalers come, over the next little while as well. Obviously, generative AI is a big thing in the industry in general. And DB2 continues to see how we can play both within the generative AI space, and we'll talk a little bit about what we're doing in that, but also use generative AI ourselves. So some of those capabilities are in the engine, such as the ML query optimizer, the AI query optimizer, as well as what we're doing with the DB2 Intelligence Center with the DB Assistant. We're going to do a major overhaul of the management console that was sort of pre-released for the cloud experience in the early part of this year, and in June you'll see it come out for the general software development use cases. DB2, of course, the engine we continue to focus on and deliver mod packs over the course of 2025, and you've seen what our roadmap looks like for that. So RDS, or AWS, we continue to have a big partnership with AWS, and DB2 is available on AWS in all topologies in some form factor. So, DB2 Warehouse on cloud is a managed service offered by IBM, so we run that managed service. On the transactional side, we have DB2 RDS, where we partnered with AWS, where they manage the service. So it's an RDS managed service, but DB2 is part of that ecosystem, and we work with them on providing, the capabilities they require to run that service with DB2. Through the marketplace, you can deploy DB2 PureScale out on AWS. So this is an easy way for you to deploy DB2 PureScale infrastructure as a service. It gets you up and running on AWS infrastructure very quickly without having to do a lot. But after that, you manage the system yourself like you would on premise, just using the infrastructure of AWS. And we'll talk a bit about how we've improved on that in the 12.1.2 timeframe. And of course, we have our reference architectures for the containers. So if you want to run DB2 in containerized software, but you don't want to manage service, you want to run it on your own self-deployed Kubernetes or OpenShift cluster in those AWS services, you can do that through the container reference architectures. So bring your own cloud for Azure. So DB2 Warehouse, Netezza as well. I'm going to come to Azure through this process. So DB2 SaaS on Azure, our fully managed offering, DB2 Warehouse SaaS, fully managed warehouse offering, are coming through what we call our bring your own cloud model to Azure. This is slightly different than how we do the managed services on IBM Cloud and AWS right now. What bring your own cloud means is that we will deploy into your own infrastructure as opposed to us owning all of the infrastructure, everything being a closed box. We own the control plane and therefore, continue to manage that as well as manage the service. But when you purchase DB2 SaaS on Azure, you're going to give us some hooks into your account so that we can deploy out onto infrastructure, given from your own Azure account, allowing you to use your own credits to spend on the infrastructure. It also means that you can run more closely within your own networking environments, so your applications and your database are now closer together in the same sort of networking interfaces, giving you a much more control over that. Gives you more direct control over the data that resides because it's still residing in your account. It's not leaving your account. Obviously, we are managing it, so we expect you not to make any changes or do anything there, but it does give you that level of control. So it's a different way of providing the managed services. You'll see this probably come out in other hyperscalers as well. And on Azure, we may bring a fully managed service as well because they're not necessarily one model fits everyone. Different people have different use cases, but this is how we come to Azure to start with this bring your own cloud model. We also have Azure Marketplace support for PureScale. So PureScale can be, again, delivered out through infrastructure as a service on Azure through their marketplace. Again, it's infrastructure as a service, so this helps you get it up, running, and deployed. But once it's there, you manage it the same way you would any other DB2 PureScale installation. On Azure, we have RDMA support out of the box because there is RDMA adapters in the Azure ecosystem as we have on premise. For those customers though that are running large warehouses and want to remain on premise, they're not looking to move to the cloud quite yet. We also have our IBM Db2 Warehouse on Power 10 Cloud Rack, which will continue to modernize and uplift to the newest mod packs of DB2 as they come out. And so this is just a flexible way to run DB2 using our container technology on a predefined hardware stack that we have partnered with our friends in the system team to provide. And we talked a lot about the containers as I went through this. The container continues to be the backbone of a lot of what we do. So our services run on it, the Power 10 runs on it. And we, of course, have the reference architecture. So we continue to look at how we can invest and evolve that DB2 universal container that we have to support all the use cases we have, as well as provide more capabilities to customers moving into a container and cloud-first approach. So on the AI-powered, Gen AI being used to help you do your job, one of the things we've done is we've come out with the DB Assistant. It's part of the SaaS consoles that we have for DB2 and DB2 Warehouse, but it will come into what's called the DB2 Intelligence Center, which is coming out in June. And this allows you to use basically, a chat interface to interact with the consoles to ask questions. It can help you get questions from the docs, and this is better than Googling because it knows what version of DB2 you're running. It's going to get you the correct answers from the docs that are context aware for your installation. It also allows you to interact with the monitoring data within the console and the console repository, giving you some ability to use sort of AI chat type prompting to get you the insights you're looking for from the data. Obviously, we plan on advancing this to do more troubleshooting, more deep dive troubleshooting, as well as more tuning. So, how can we use advanced analytics to help you with, performance issues, query plan analysis, etc. So those will evolve, not necessarily I'll be there when it comes out in June, but will evolve over the life of that product. So it's just, a screenshot showing the improvements that are coming, look and feel. So, the entry hub, the monitoring hub, the workbench, all have a new look and feel of a more modern and more consumable approach to the console. A new product called IBM Db2 Bridge was released alongside our Mod 1. And this is really a one-stop shop for how you do data migration, data movement, and will evolve to also include in sort of how we do, third-party migrations like Oracle and Teradata, translation and movement into DB2. So it's sort of focused on DB2 movement, and we'll move into the deeper migration type operations over its life. It can integrate with HPU and some of the other technologies to orchestrate and speed up those data movements as well. Although you need to have a version of HPU, it doesn't come with it. So that's the DB2 Bridge, helping with the simplification of doing those migrations of data movement from different topologies, whether it be from on-premise to on-premise or whether it's on-premise to the cloud. So we look at other generative AI capabilities for DB2. So, we talked about the database assistant already. That's our using AI in the console to help better help DBAs do their roles and their jobs. But we also are looking at how we can integrate vector search. So you'll see that in Mod 2, we're coming out with a vector type. We'll talk a bit more about it then. And then if we look beyond Mod 2, we're really looking, how do we integrate with LLM services? So how do we allow you through SQL, through DB2, reach out to those LLM infrastructure you may have in your organization, get embeddings, get prompting from those LLMs and bring it back and integrate it all together with the data you have in DB2 without having to move data around. Just a slide showing, a quick test that we ran when we did DB2 12 versus Postgres 16.4. And what we found is that, DB2 and Postgres on the same hardware, there is, a difference of maybe 2 times in the configuration we had. But what we found is as we scaled up the hardware so that we could see how things scale, DB2 reacted and used that additional hardware and memory much more efficiently than Postgres. So Postgres continued to perform relatively the same regardless of the hardware underlying the databases. Okay, so this is the 12.1 eye chart. We were pretty aggressive with the operating systems we moved up to because we want to make sure these operating systems live through the life of 12.1. We don't want people to have to necessarily move, some way in the midstream of 12.1, and a lot of the operating systems that we were running on and supporting in 11.5 are either out of support or near there. So we did move to 9.4 for Red Hat, 15 Service Pack 6 for SUSE, AIX 7.3 TL2, and Windows 11 and 2022 as a server. We did deliver out the Mac driver support, so you can run the Mac clients on the M1, M2, and M3 ARM chips. What we are not delivering with 12.1 is an Mac Intel-based driver. So if you need to run on Mac Intel hardware, you can continue to use the 11.5 driver. It will, for most capabilities, be just as available. There aren't very many differences that are unique in the 12.1 client. So 11.5 clients can continue to obviously talk to your 12.1 databases. Obviously, from the container perspective, we've moved to OpenShift UBI 9 because that aligns with the RHEL 9 support that we have as the base for the engine. So, doing so, we realized that in order to support the upgrades, there was some gaps when we originally shipped 12.1, especially for PureScale. For non-PureScale, there wasn't as much of a gap because we always are upward compatible. We had RHEL 9.2 support, so RHEL 9.4 was implicitly supported because of upwards compatibility. But for PureScale, we're more prescriptive. So we have, with the 11.5.9 CSP, delivered out the required RHEL 9.4, SUSE 15 Service Pack 6, and the AIX 7.3 TL2. Now that we have the dependencies, for those platforms for PureScale in the CSP stream, the GPFS upgrades and the TSA level upgrades that are required. So it is now possible to get to the latest 11.5.9 CSP and then do your upgrades to of the OS and then your upgrades of DB2 to get up to 12.1. On 12.1.1, we closed the gap around SUSE, so that was 15 Service Pack 6 for PureScale. We had hoped to deliver that with GA, but because of some of the dependencies on the dependent products, we had to push that to 12.1.1. We also, with 12.1.1, got the NVMe reservation out for AWS. So you'll see that we continue to evolve our story around PureScale on AWS to try and get those higher end write workloads capable of running in the AWS infrastructure. Amazon Linux 2023, Ubuntu 2024 is tentatively scheduled for Mod 3. Windows Server 2025 is also, looking at that for 12.1.3, and of course PureScale on the more up-to-date service packs of the RHEL stack and AIX and SUSE. Now, if we look beyond 12.1.3, we recognize RHEL 10 is coming, and we want to get there quickly. We don't want to be like we were in 11.5, pretty late to get the game with RHEL 9, because it just makes everyone's ability to move forward drag out, and therefore challenges more at the end of the release. So we were hoping to get that, early in probably 2026, but we need to see the timing of when RHEL 10 comes out and what the amount of effort is on our part to support it. Same with SUSE 16, and of course, AIX 7.3 TL4, as it comes out, we will certify and move forward with it. All right, so if we look at 12 again, just to recap some of the bigger items that we delivered in the 12 release, PureScale, HADR, DPF support on Linux is now all on Pacemaker. It is the only integrated cluster manager we ship on the Linux platform. On AIX, all of those remain with TSA. So it's really us focusing on the platform manager cluster manager for the platform. So Pacemaker has sort of become the de facto cluster manager for the Linux environment. We want to be there and play with that because it's much more integrated into that environment. TSA remains sort of the cluster manager of choice on AIX, and so we'll continue to use and leverage TSA in that environment. Namespace separation, aka what we call tenants. This is a logical separation or an application level tenancy. It allows you to have an extra namespace, so you have tenant before schemas, allowing you to deploy the same schemas and tables without having to play games with renaming schemas into the same database. So you can basically have multiple copies of the same application hosted and running in the same database. But operationally, you're still managing the database as a single entity. Backups are at the database level. You can view monitoring and all of that is at the database level. They share resources, which is the benefit of tenancy versus independent databases. If you really need isolation at the database operational level, then we do support multi-database still within the instance, and that is still an approach to get that. This is really about allowing you to share memory and CPU resources within a single database without having to subdivide those, and therefore have better control through W11 stuff of the sharing. The AI-powered query optimizer that we had sort of tech previewed through the life of 11.5 has come out in 12.1, and this really provides a way to get much better query planning through better statistics analysis. We'll talk a little bit about that in a couple slides. We talked about the Gen AI, infuse that in the DB Assistant, and we're looking at how we get generative AI capabilities in the engine so you can run your generative AI applications using DB2 as the store. Backup improvements, intertable-based parallelism. We talked about the driver support on Apple Silicon already. And one of the other things we delivered in 12.1 is the ability to use HADR, reads on standby, to provide at least reads operations through the upgrade process. So while it doesn't give you, full availability, it does at least provide some level of availability to minimize the impacts of the downtime required to do that upgrade. Peer scale, we brought in the SSL encryption, and really this is just a lot of the theme of 12.1 GA was to make the changes that are somewhat impactful around security and get those out in the GA level so that we can make DB2, more in line with security practices of the day. Admin move table performance enhancements. Schema evolution for columnar tables will be a theme of 12.1. The drop and rename came in GA, and you'll see over the life of the mod packs, we will bring in more alter support for columnar tables. Performance improvements around joins and update on columnar tables. The completion of sort of what we call the compact bar chart work, the better usage of memory around join and operations is sort of complete now with the more complex join work being delivered out in 12.1. And of course, we continue to enhance federation as it is a key component of the DB2 ecosystem, with both keeping up to date with the data sources that are evolving, but also looking how to better exploit and optimize for those data sources. So the AI optimizer, really what the AI-powered query optimizer does is it allows us to better analyze the statistics and relationship between statistics to get better statistics for our cost-based optimizer to make decisions. What you can see here is that on the right-hand side, we delivered, if you ran a workload, you can see that for the most part, with the traditional optimizer versus the AI optimizer, we get much better plans under the AI optimizer, much faster things. Obviously, there's some outliers where the query weren't very long running to begin with, because obviously we probably had a fairly efficient plan to start with, so it's not going to make much difference. But on those longer plans where the join orders really are influenced by even a little bit of misinterpretation of the number of rows flowing through the plan, you can see we can get a much better query run times. The focus right now is on cardinality estimations, but we are extending that to more complex and even looking at how we can look at and model interjoins between tables. So this just sort of shows sort of the difference at a plan level and at the stats level. So on the right hand side, it's really showing that with the model based statistics, we get very close to that zero, which would be perfect statistics analysis. Column group statistics helps. It reduces the box, the window for bad inference on top of the statistics quite a bit. And then you'd have the general statistics that we collect in the white box. What that meant is in this plan example we have is that you can see that on the left-hand side, we misestimate the number of rows flowing out of a join. And because of that, the join order, is influenced based on that. On the right-hand side, you can see that the number of rows flowing out of the table scan becomes much more accurate with the model. And then because of that, the rest of the join orders are also getting much better estimates on how they will impact the query, and therefore we get a much better query plan flowing through. Talked about this a bit. So if you move up to the latest 11.5 CSB, this is required for the HADR read access during upgrade, because we did need to make some changes in 11.5 in order to put us into a safe mode where we recognize we are doing this upgrade processing while the database standby stays up. But what that'll change to deploy that, you can now deploy, keep your HADR standby up in read mode while you upgrade the primary, then, take it down and do the upgrade of the primary and catch up. So there's a process for how to do this. And, if you follow that process, you can at least get read access during the upgrade process. Intertable space backup. So this is just showing that, we saw, assuming you have both CPU and bandwidth in your I/O systems, we can see a 2 times improvement where there's considerable skew in the data containers. As we move to the right, we reduce the amount of skew, and obviously what we're really looking for is the right-hand side, which proves that with the algorithms we're using, that if you already had done all the work to balance out your table spaces, we don't regress how your backup performs. Obviously, we can't improve it because you already have the data properly parallelized from a backup perspective, but we didn't regress. And as we move to having skew, we can use our algorithm to parallelize those longer pull table spaces and get them to be less likely to be the bottleneck of your backups. This slide is really just showing the if we over provision I/O, we can even get a 4 times improvement. So we added a second fiber channel card just to increase the amount of I/O bandwidth, and the same sort of picture, right? We got a much better improvement where there's skew, and of course, we did not regress as we moved down to the balanced case, which was good to see. A couple things to be aware of is that, pacemaker, we talked about that on Linux. ICU going forward will change in mod packs, and we will not be carrying forward all of the legacy ICUs like we had in the past. This does mean that if you use collation, be aware of where you use collation. Don't use it in indexes or places like partitioning keys, because if the collation changes, then it could impact the sort orders. And if the sort orders changes, then we will have to invalidate those operations and objects. But for the most part, most customers don't do that already. It's really that you just need to be aware that the sorting, if the collation for your language changes, you may get a new sort coming out of the database to align with what the new collation is for the language you've chosen. It should only affect some very small set of collations. This isn't really across the board. It's really, there's some legacy collations from when we first did ICU that we know have changed and will not give you the same sort in V12. Okay, so 12.1.1 engine changes. We completed the online index reorg for peer scale work. This really was the work to get online index reorg up to par with what we had for non-peer scale for peer scale. We had hoped to get it in 12.1, but came in 12.1.1, so that's good to see. The AI optimizer, we did some work to better enhance the explains so you better understand how the models are impacting and helping you with your query optimization. We had some columnar improvements really around fetch first n rows, so we can now use fetch first end rows and have it apply down deep in the columnar engine much more efficiently than in the past, providing improvements for queries that are using that to try and break out after seeing a few rows. We enabled section actuals for columnar tables. It doesn't necessarily cover all the section actuals because of the differences in how the columnar engine is planned versus sort of how our row engine and the explain plans look. But where we could provide details, we do now provide details. So providing better insights into how the columnar engine is running at, in actual metrics. Well, one of the things we added in 12.1 GA, which I didn't talk about, is the ability for DB atoms to now manage buffer pools and table spaces over automatic storage pools that are already predefined in the database by the sysatom. So decoupling the sysatom requirement for buffer pools and table spaces as part of separation of duties. We've now added a table space atom authority as well, and we'll talk a little bit about that in a slide, and some SVM uplifts. Container, we continue to deliver more of the capabilities out on platforms. So our open data format for our DB2 Warehouse product is now available in the DB2 Warehouse containers, one running on PowerPC Little Indian. Key Protect compatibility integration, and the stack refresh for that B10 Cloud Rack that we talked about. On the cloud, they moved up to the newer engine, some local LDAP password policy work, as well as PureScale as an infrastructure in Azure. Talked about that. The DB2 Bridge for data movement and migration capabilities was also came out in the same time frame. So table space atom. So this really just allows you to separate even further than what we initially decoupled in GA. This allows you to delegate the table space administration to a specific person, assuming the data is in an automatic storage group, because if the sysatom provides the storage groups and already says this database has access to those storage and it can grow, there's really no reason why the database atom or the table space atom cannot provide how the database uses that storage within the database itself. Similarly, we added the new use privilege on the buffer pool, allowing you to give out usage of buffer pools to table spaces without having to have sysatom control. So just trying to remove the level of granularity that you need to have, allowing the sysatom control to give space within the storage layer to a database, and then let the database itself administrate how it uses that storage without having the same levels of the authorization being required. Undying index reorg, really, the problem being able to rebuild the indexes to get a better index structure without having to do an outage, take an offline window. So with PureScale, you can now do reorgs with online and get the same access you had without PureScale environments. Rebuild can start on any member, but you can only have one index reorg running for a table index at a time. So if you start one on one member and start one on another member, the other one's going to fail. Multiple instances of rebuild can happen concurrently against different tables, and those can run on a different mix of members. But for a given set of indexes and tables, you have to run it on a single member and only one command. So it's not really much different than on premise. You could only run the command once for that set of indexes. It would just naturally be only on the same member. So the cross members protection is in place. If you're rebuilding on data partition, it locks the partition where all of the other reorg rebuilds lock the table. So 12.1.2. So one of the main things we've done with 12.1.2 is we introduced the vector type and some similarity search scalar functions. And we'll talk a bit more about those in general. And this is really setting us up to deliver on sort of that generative AI as a data source capabilities, and we will be iterating over the vector work through the life of 12.1. The AI optimizer model and performance robustness is null predicate, so more cases where we can use the model and basically model generation improvements as well to make the AI optimizer more efficient and more useful. PureScale, you'll see us deliver the Elastic Fabric adapter support. So this is really the ability to get an RDMA-like environment on AWS. So EFA is sort of the closest equivalent to a pure RDMA environment on AWS, and this allows us to integrate and get those higher write workloads running in that AWS infrastructure as a service that we talked about earlier. So with 12.1.1, you'll be able to deploy out onto machines that have EFA, and we'll take advantage of those EFA adapters to run those heavier write workloads. We also integrated Z-Linux hypersockets and ZVM support, just giving PureScale more flexibility on running on Z-Linux and Z hardware. So if you have a Z-Linux environment, a Linux 1 environment, you can take advantage of hypersockets, or you can even set up some VMs that are going to run just pure sockets for test dev purposes, possibly, and leaving those RDMA adapters for the higher end workloads that are running on those machines. Dated masking at read, we'll talk a little bit about that, and world writable file permissions. Again, we'll talk a bit about that in a second. Remote storage, because we moved to Azure, we brought Azure into our remote storage architecture. Obviously, we need to support their blob storage support in our own services, and now it's available also to other customers who may be running on Azure or have need to access it remotely. So you can backup, restore, load, etc. From Azure blob storage now. Some monitoring around TLS and SSL times, so you can see how much of your network traffic is really being impacted by maybe using SSL. The data lake table support, iceberg tables with update will be delivered, and we've completed out the section actual work. So there's still some gaps, but for the most part, there's more entries where we think we can map the section actuals that actually happened down in the column engine up to the plan, and where that information is possible, it is now all in place. Where there are gaps, we don't plan on solving those, at least in the short term. Containers, what we've done is we've added in GSS plugin management, Kerberos authentication, and a mechanism to really bring your own image, which is really allow you to have third-party applications in a container environment. This is really a way for you to, a process for us to say, you can build a container with your own third-party software you require, and then bring our images into that container to build a new container that would service both DB2 as well as your own applications. On the cloud, we're going to bring data lake tables to our smaller single node DB2 warehouse offerings. And of course, we talked about bring your own cloud for Azure with the SaaS offerings. So removal of world writable permissions. So we know that one of the challenges we have is because we have an embedded client in our servers, and we don't know what users or applications are using the client that happens to be part of the server. We've generally had a bunch of permissions that were world writable and world readable. We're not solving the world readable today, but that is, in the life of 12.1, something we plan on tackling in much the same way as what we're doing here for world writable. So what we've done is we've come up optionally to allow you to give us a group. So you can say when you either updating the instance or during installation, you can say this is the group that we want to be able to access the clients. The DB2 instance obviously has the part of that group as well, but allows us to basically say this is the group of users that will need access to those files, and then we will make that group the owner of the files instead of making them world writable, and then it's the onus of the administrators to make sure that that group that you provided contains all the users that need access to the DB2 clients or the instance or the defense mode process, etc., to access the DB2 files and have write access. This will, get us closer to what we had on Windows with the sort of Windows extended security model that we already had. So it really provides an ability to reduce that exposure of world writable files, and hopefully helps most of our customers who are seeing this being flagged by many security software in their organization. So just to enable it, you can use the iCreate, gives us the shared group, and we will update it. And again, on install or through the update process, you can do that. On the drivers, you can use the DB2 CLI tool to add that groups for the clients. So this is a way to ensure that even our clients can now remove the world writables if required. When we update, if you're updating an existing instance, we will be searching through and changing the ownership of the files as we go. So make sure that group has everything it requires set up ahead of time. So vector, what is a vector? So a vector really is just a list or an array of numbers, and they present a point in space. You can think of them sort of like a map where you have coordinates, and it sort of tells you the distance. Sort of encapsulates what that location of a given entity is, much like a map with coordinate systems, and you can then compute distances between a pair of these vectors in order to try and figure out how close or similar they are. So in 12.1.2, we introduced the vector type. The vector type, data type, as we implemented it, will support both a 32-bit float, so standard sort of float capability, as well as a 1-byte integer, an int8, giving the most flexibility for really compact vectors, as well as the more common use case of floating point numbers. Obviously, depending on what type you use, the max dimension of the we can store, because we store this effectively in a representation much like a bar binary, will change. So you can get a dimension of 8,168 with float 32, but you can get up to close to 32K with the int8. To create one, you just you would create a table, give us the column name, and then you say it's a vector. You tell us the dimension, and you tell us what type that vector will represent. So 100 dimensions, real, or 300 in int8. Really, for the most part, this is a server type only, in the sense that we don't flow the vector as a type to the client. When you find out when it leaves the server, we will serialize it into a varchar or a clause. You get the textual format of the vector representation. Vector distance, so the ability to measure, the space between two vectors. We support both Euclidean, which is like a straight line distance approach, Manhattan distance, which is a sum of the absolute differences, or cosine, which measures sort of the angle between the vectors as ways to detect and determine similarity between vectors. So the vector distance function looks like this. It takes in two vectors, as well as what algorithm you want us to apply to determine the distance between the two vectors. Cosine dot, which is a variation of cosine, as well as Euclidean and Euclidean square, Hamming, and Manhattan. And then there's just a simple example that shows, if you take two vectors that are very similar and tell us to compute it, we will tell you that they match, which is good. But if the vectors were different, then you would get some other mathematical, result out of the distance, which would tell you how similar, relatively speaking, they are compared to other numbers. Of course, you need to be able to build vectors, and obviously, as we talked about, we don't send the vectors back. You need them in text form. So there's the vector constructor, which will take in, a scalar or a string representation of the vector, and then produce that binary vector that we use internally. So the vector type takes in sort of the string representation, takes in the dimension and the type of vectors that are encoded just in that string to provide that vector data type. Serialization is kind of the reverse. It takes a vector and it will produce out the similar text format that was originally inputted. Couple other helper functions. There's a vector norm, which just helps you normalize things if you need to. as well as a vector dimension count. If you just want to figure out how many elements are in a given vector that you might have available. There are a bunch of limitations with what we're delivering in Mod 2. I would say this list, and I won't go through every item, but for this list, for the most part, we hope to address, I would say, 90% of it in the Mod 3 timeframe, really bringing vectors into the sort of full SQL ecosystem. The one outlier I know is ingest. We probably will not directly have vector support in ingest, and wait and see how that plays out. It doesn't mean you can't use it, because obviously you can send strings, and once we have the casting capability in place, you can just, as long as the client side sees them as strings, you can send them up and we will cast them or serialize them or construct the vectors properly on the engine side. It's just more about knowing that it's a vector within the ingest tool, and doing any specific ingest operations around vectors is probably not going to come. Load, though, will be fixed, so we can load them versus having to use ingest message. Same with external tables. So those gaps will come with Mod 3. But there are a bunch of things about a vector that really just don't make sense. There's really no way to compare two vectors to say they're equal. So therefore, you can't really sort them. So a number of things like, making them a primary key, a foreign key, or a unique key, use them in indexes or order bys, or distribution keys or partitioning keys. Those are gaps that will stay, for the most part, at least in the short term, as hard restrictions around a vector type. So this is more of the list of things of where you can't use a vector type versus necessarily restrictions of the original implementation. And then RCAC column masking. So this is just to set up the stage. So we have RCAC. This is a way for you to apply different rules on row column access. One of the capabilities you can do is you can define masks. You can say these columns should be masked in a specific way using, a case statement, and you can put functions and stuff in those case statements. What we've done in 12.1.2 is we have allowed you to add the ability to mask at what we call read. So the original masking capabilities that DB2 has had is always what we're now calling sort of mask at result. We kept the masking until the later stage before we actually flow the data out of the database engine in order to allow most of the SQL operations to be compatible that you would normally run within the engine, because they will operate on unmasked data. The challenge with that is there is the ability to do some inference if you have the right access privileges. So what mask at read does is it removes the ability to do any inferencing. It also limits where you can use it, because if you're doing joins or anything with the masked data, now the masking must be some compatible masking operation in order for the joins to make sense. But at least doing the masking at read will remove that inference capability. So with 12.1.2, you have the choice. You can create them as you did in the past at result, or you can create the mask at read, in which case we will apply the masking as soon as we read the data off, or really before we apply any other operations in the process. So when we take it out of the buffer pool, it's not really directly at read time, but as the data moves out of the buffer pool into our runtime to be operated on, we will mask it immediately, and then no one can make any decisions on the read data. We do allow you to have restrict and allow joins. So, if you say at read, the problematic thing is that now where having in join things are going to see mask data, and you won't necessarily make the right decisions depending on what you're comparing to. Whereas the result would have looked at, processed that, and then looked like the masking. So what we've done is we've created this restrict usage clause, which basically means that instead of giving you results that may make no sense, is we will fail. So we'll return an error saying you're trying to use mask at read column in a use case where we don't think it applies, and then we'll fail the query. You can choose not to apply the restrict usage, and then we'll apply the SQL as it is, the masked data versus whatever's on the other side. Maybe they're two masked results. If the masking is compatible, you'll maybe get something that's meaningful. Otherwise, you may not. And then we have the restrict usage but allow joins. And this just allows you to allow some join operations to work where the masked data can be joined safely. And so just opens up a few more use cases, but potentially a little bit more risk. We've added in a new scalar function for pi, and some synonyms around, array max cardinality, varchar format binary, and hash value, just to remain compatible with some of the naming conventions on some of the other DB2 products. And this slide, which is really looking at beyond mod 2. So we talked about it probably already. The vector work, mod 3, we were looking to complete the mock vector type, so get it fully integrated into the SQL ecosystem within DB2 so that there's less friction to using it. We are also looking at how can we improve the vector similarity searches. Today, it's a scalar function. If you provide that on your table, it would be a table scan. But if you do some pre-filtering and then apply this similarity on a subset of the results, you'll probably get fairly efficient processing, and that is the main use case we see in the short term. But we are looking at how we can bring in a vector index to allow sort of similarity searching on the sort of larger data sets. We talked about looking at how we integrate with an LLM. How do we allow you to generate those embeddings through SQL so that you don't have to leave the database ecosystem to deal with embeddings or even some prompting. And then the AI optimizer is looking at ways it can train models as well as join cardinality work. PeerScale, we continue to work on online topology changes, working towards allowing online drop, allowing for more dynamicism in how the PeerScale cluster can be managed. Rocky v2 support, and remove some of the security dependencies we have in the PeerScale thing around SCP and DB2 Losh, given the modern changes in the sort of security posturing of some of the operating systems where we place things, or the tools we use are no longer as compliant, and we are going to work to move to what those ecosystems expect us to use. We also are introducing the ability to quiesce a table space into read-only mode in PeerScale. We already had that ability in non-PeerScale, and this is a sort of a staged approach. So what we may deliver initially is maybe slightly different than what we did outside of PeerScale, but it will at least allow customers to do the same capability, same operations as they had in a PeerScale environment. External tables, unloaded quoted values. We're looking to create a generated UUID scalar function, something that I know has been asked about for a long time. Looking at some ways to use plans, bring in more plan stability using some of our profile tables, etc., to allow you to lock down how plans look. We're upgrading the DBMS lock to allow for transaction scope blocks, not just session scope blocks, allowing you to use DB2 as a locking mechanism within your applications. And as I said, schema evolution for columnar tables is a theme. So decimal precision is sort of the first one, and then sort of, how can we do some upcasting from common sets of data types, and then obviously move into the more complex cross data type alters that we support with Row. Obviously, out in the containers, we're looking at improvements around HADR. We talked about the third-party co-location. So how do we better provide for third-party utilities in that ecosystem? And of course, V12 and data lake tables being available and integrated into what we deliver out of the Cloud Pak for Data environment. This is just a subset of things. There's obviously a lot more that we're looking at and considering, but This is just to give you a sort of a feel for what some of the thoughts in the shorter term window are. So this is just to sort of highlight what we're thinking beyond 12.1.2 and 12.1.3 from a vector perspective. We're looking at indexing to help with the low latency similarity search, looking at LLM integration with REST capabilities, probably with WatsonX.ai to start, but then how can we bring that out into other LLM tooling systems? And that's really all I had. Keep in mind that there's lots of great education and availability in the IBM tech community, much like what you get with the DB2Night show, but another place to go if you're looking to learn and upgrade what knowledge you have around DB2. And that's all I have. Thank you.
Well, thanks, Mike. Thank you very much for walking us through the new features and announcements in DB2 11.1.2. It was insightful and informative. Thank you. I'm going to take the control back. All right. Thanks again, Mike. It was a packed presentation.
Okay. Well, thank you for having me. Happy to be here.
Couple of questions around ITP. When we increase the number of fabrics, it's going to increase the performance, all that, right? What is the best practice among, how do I figure out this database going to get the benefit from the ITP parallelism? I know the skewing part is one. How do I determine what's going to be my performance benefit with 12.1 backup?
Yeah, I mean, I guess if you're familiar with your bar stats already and know where your bottlenecks in backup are, that will probably be a guiding factor in where if you'll see improvements or could see improvements. If you know that you basically are bottlenecked because you have skew in a table space versus, say, CPU or I/O bottlenecks, then that's a place where you probably will take advantage of ITP. ITP is, it's on by default. We don't believe people should need to tune the algorithm we're using. So to some degree, we expect customers who can benefit will just benefit implicitly out of the box. Hopefully that is the majority of our customers who have challenges with table space skew. But there is the side effect that if really your bottleneck is, say, the I/O availability either in the database, probably not, because you already have the I/O to run the workload. But maybe you have I/O bottlenecks on the storage target where you're backing up. Maybe you could look to improve this target I/O bandwidth, and then we can maybe improve the backup by parallelizing it better out of the database.
Great. Thanks, Mike. All right. So today's show sponsor, DPI, Smarter Tools for Smarter People. This supports DB2 SQL Server. This is now given to you with thin client. You don't really have to have a client installed on your laptop to view the performance statistics, and it gives you much better statistics around how database is doing, what are the best performing, what's performing SQL statements, all that information in one keystroke. Right. With that, we're going to be closing the call. Thanks everybody for joining. Thanks, Mike, for walking us through again.
Thank you for having me.
Have a good day. Bye-bye.